GCSE Biology, Stopping Distances, SMARTPATH Tutoring. Many factors affect your total stopping distance. 1. In an emergency, for example a hazard ahead in the road, a driver may perform an emergency stop. This is where maximum force is applied by the brakes in order to stop the car in the shortest possible distance. The longer it takes to perform an emergency stop, the higher the risk of crashing into whatever is in front. The distance it takes to stop a car in an emergency equals stopping distance equals thinking distance plus braking distance, where thinking distance, the distance the car travels during the driver's reaction time, the time between the driver seeing a hazard and applying the brakes, braking distance, the distance the car travels after the brakes have been applied until the car stops. Typical braking distances: 14 meters at 30 miles per hour, 55 meters at 60 miles per hour, and 73 meters at 70 miles per hour. Thinking distance is affected by speed. The faster you go, the further you travel during the time you take to react. Reaction time: the longer your reaction time, the longer your thinking distance. Braking distance is affected by speed. The faster a vehicle travels, the longer it takes to stop. Weather or road surface: if it is wet or there is ice or oil in the road, there is less grip and less friction between the tyres and the road. This can cause the tyres to skid. Condition of tyres: if the tyre tread is worn, they cannot get rid of water effectively in wet conditions. This can also lead to skidding. Road surface: brakes work less well if the road is bumpy because the wheels can lose contact with the road, reducing friction. Safety: you need to be able to describe the factors affecting stopping distance and how this affects safety, especially in an emergency. Increasing the stopping distance means there is a greater chance of crashing. The longer the stopping distance, the more space needed in front to stop safely. Speed limits are important because speed affects stopping distance so much. Braking relies on friction between the brakes and wheels. When the brake pedal is pushed, this causes brake pads to press against the wheel discs. The work done between the brakes and wheels transfers energy from the kinetic energy stores of the wheels to the thermal energy stores of the brakes. The brakes increase in temperature. The faster a vehicle is travelling, the more kinetic energy it has. More work is needed to stop it. This means a greater braking force is needed to make it stop within a certain distance. A larger braking force means a larger deceleration. Very large decelerations can be dangerous because they may cause brakes to overheat, so they don't work as well. The vehicle to skid: you can estimate the forces involved in decelerating vehicles using typical values. Thank you for watching. Please don't forget to subscribe and like the video.